have out your foldable, you are going to use the practice section, the last page, in order to go over this test one step at a time and make corrections on the test itself. Okay, so remember, you have your changes of your y, those were increasing by 3, and your change of x, those were increasing by 4. So I wrote 3 over 4. Yes, you have to flip these two numbers. And that, because they're all 3 over 4, it is linear. Now over here, we have 10 over 1, 20 over 1, and 40 over 1. Those are not equivalent to each other. And yes, you need to write these fractions as your explanation, and those are nonlinear because they are not equivalent. Now what I don't want to see is they're not equivalent because these numbers are different. That is not true, because you can have different numbers down here and different numbers up here, and then they are equivalent. For example, if I make this a 2 and the change here is a 4 because that was a 3 and a 7, then I divide these two. 10 divided by 1 is 10, 20 divided by 2 is 10, and 40 divided by 4 is 10. So do not tell me it is not equivalent, because these are different. They can be different, and so can those. They are nonlinear because those are not equal to each other. Okay, so your pattern, increasing by 3, increasing by 4. Right? 3/4. It's 3/4 for all three of them. So it is a constant rate of change. It is linear. If you write this one, 15 divided by 3 is 5. 33 divided by 3 is 11. And 51 divided by 3 is 17. Those are not equivalent to each other. So no constant rate. It is a non-linear answer. Yes, you must write the fraction and the linear. You must write all three fractions to prove and explain, like it says in the answer, explain that it is nonlinear. Again, do not say it's because these are different. That is not why that is nonlinear, because these could be different also. Okay, make sure you're copying your rate of change or slope right here. Copy the negative. And whatever's added or subtracted is your y-intercept. 4 is your slope or rate of change, and the -7 y-intercept. So same thing, -2 here. Slope is the same thing as rate of change, +5. Slope is the same as rate of change, 3, and that is a -7. Okay, again, the change of 10 divided by the change of 2 is the 5 right here. That's the red number. You automatically put your x next to it. Whatever's across from 0 is what you add. Same thing, -3 divided by 1, that is this -3. Put your x next to it right away. Whatever's across from your 0, meaning under the y section, is what you add or subtract. Okay, so you have your difference of 50, that's a difference of 1. This is a difference of 100, difference of 2. Difference of 200, difference of 4. A lot of y'all are telling me this is nonlinear, which is not true, because 50 divided by 1 is 50. 100 divided by 2 is 50. 200 divided by 4 is, guess what, 50. Automatically write your x next to it. Now if you backtrack to find 0, I subtract 50 from 50 and I get 0. That's why there's nothing added in this equation. It is a 0. Your y-intercept is a 0. So here we go. Your change is -3s, your change is 4s. Yes, this number, your change of y, has to be on top. Your change in x has to be on bottom. Do not separate those. Those are a fraction and remain a fraction. What's across from your 0? A -1, and that goes right there. Okay, y-intercept, it is a 5 right there. That's where the +5 comes from. You find a spot along the line that you could read. You could read this one here. That's a change of 3 because these are 2 each. So that's 2 plus another half is 1. This half is 1 plus another 2. So it's 3 divided by 3, which is 1x. Same thing. You find that equal spot. It comes out equal right here. Do not use this because that's not exactly on that 5. You can see that little triangle right there. So that's a 3 and a -4. That goes right here. The y-intercept is easy, where it crosses this line, which is the +4. So apply that. Okay, so you're doing the same exact strategy. That crosses this y-intercept. Where does it touch? Oh, right there. That's a -3. Now you find that triangle. It ends right here. See, this is not even. It does not hit 1, but like -2.5. I don't want to deal with the half. That is a little triangle right there. Do not count that one. That's a little triangle. Do not count that one. But this is right at the 5. So that is a 5, and that is a 3. Write this as a fraction, 3/5. And you have 3/5, and you put your x next to it. And you have your -3, because that's your y-intercept. Over here, automatically y-intercept is 2. 1, 2. So you put +2. Draw your box. Came out right here and right here. That was down 2, right 3. Put a line in between it, and you have that fraction. You put that next to your x, or your m, your slope, which is the same as your rate of change. Okay, first, graph it along this line. That's a -1, so it goes right there, and you put a dot. Now to get directions from that dot, you rewrite the 1/4. Rewrite the 1/4. The bottom number is always right. See? It's always to the right. The top number is up or down. This one's negative, so guess what? Down. This one's positive, so you go up. So let's start at the -1 right here, and you're going to go up 1, right 4, and you get that other dot. Draw the line to connect them. You go over here, you're starting at the 2 along this line, so put a dot at the 2. You go down 2, right 1, down 2, right 1, and you connect those dots. And these are your directions. Write your M and directions on the test. Write it all out. So what you get when you take the test, you have this +2, put a dot at the 2. You then rewrite the directions. That's a -3, just like your review, it was a -2, and you're going 1. So down 3, you're starting at the 2, and you go down 3, right 1, down 3, right 1, because that's a negative, it's down. This bottom number is always to the right. Okay, over to the other one, positive. Now you're getting directions from there. Up 2, right 1, so start here. Up 2, right 1, up 2, right 1, count accurately.